Are you understand? See, this is a program. I'm using begin here. So this is initial begin. Yeah, I'm initializing the flag and I. To start with the disabling button named block, you should go with what? Begin colon block 1. This is a begin colon block 1. So I'm writing while with the condition I is less than 16. Begin. If my flag of I, if it is true, what I'm doing, I'm displaying this one. If it is false, it is going to incrementing the I. Again, it is checking for until it is true. Once if it is true and it is executing this, printing the true value of the bit, now what I'm doing? I'm disabling this block. What is the block name I am named this? Block 1. So how to disable this? Using disable keyword. Disable block 1. See here I have named the block. How to name the block? Using begin colon, give the block name. Whatever, it need not be always block 1. You can give the any name. Now I am beginning naming the block. Now once I am using disabling here when this condition is true. Once it is find out in the true value of 1, then what I am doing? I am disabling this block. Once you disabling this block, now it is not going to increment the I value, it is coming out here. Did you understand? I said this is the use of like what? You can achieve using what? Continue and break. Using what? Naming block and the disabling. Naming block and the disabling. Is this is clear? You can take up this program and execute and see the effect of this program. How this is working as a named block and disabling the block. You can write multiple loops. You can control the multiple loops with the named block and the disabled block. Is this is clear? So with this, we are covered with the behavioral model of style of programming. So there is a one concept is there, generate statement. So let me talk about that generate statement in the upcoming session. Okay. So this covers the complete what? Behavioral model. So let us recap what we talk about in the behavioral model is. The behavioral model, what is the basic building block for the behavioral model is? Always block. Always block and initial blocks are the procedural statements. Procedural blocks. How initial begin will execute is nothing but only one time in your simulation, where always will be continuous loop structure. So what is the characteristics of the always block? Inside the always block, if you are using the variables at the LHS side, it will be what type? It should be right integer or a real time, correct? But not it should be what data time, net data time or while data time. So we talked about the one always block with the some of the combination logic circuit and sequential logic circuits. Then we started talking about the timing control. Timing control in the behavioral model. 3 types of timing control. Those are delay control, event control, level sensitive control. Again, delay controls are 3 types: regular delay, intra delay, and zero delay. So event control is timing control is nothing but regular event, named event, event or control or event or control event. 3 types of events. Then we talked about the level sensitive event using a wait keyword. Right. Naming is done using what? What keyword we are using to name the event? Naming event. Giving keyword I call it as an event. Correct? You are using the event keyword to name the event. And then when you are triggering this, you are using this icon with greater than named event. Okay, this is rarely used. Not most of the time you will not go with what you mean. Named event. Used to prefer the regular event or control event. Then after talking about the timing control event, we started with what? First we started with procedural statements, initial block and always block. Then we talked about the blocking assignment, procedural assignments, like a blocking assignment and non-blocking aside. The way they are blocking statements are executed and non-blocking statements are executed. And we also understood that when to prefer blocking statement, when to avoid the non-blocking statements. And then after that, we talked about this, all these timing controls. Then after this, we talked about what? Control structures, like what? Conditional statements, multi-branching statements, then loops. Four types of loops: for, while, repeat, and forever. Then last topic is nothing but how sequential blocks are executed, how to make the parallel block execution using poke and join process. Did you understand? So let me talk about, there is one last topic is the generate statement. What is the use of the generate statement in behavioral model? Let me talk now. Okay. Now let us give few exercise to you on the behavioral model. Can you find the solution to each problem? Let me give the exercise for sequential behavioral model. Behavioral model. Can you write the answer to one by one? You see, this is a one question. Declare a register called oscillate. Declare a register called oscillate. Initialize to 0 and make it toggle every 30 time units. 30 time units. Do not use the always statement. This is some sort of clock generation only. He's talking about clock generation only. Instead of the clock, he is talking about register, call it as what? Oscillate. So he is giving int also. What is the int to this? Is nothing. Forever. Can you write a program to this? How to write a program? Initial, this will be declared as a reg. Reg oscillator, initial, begin. What do you need to do? Oscillate is equal to what? One take B0. Then what do you need to do? Forever. What is the time unit he is talking about? It may toggles every 30 time units. Is it hash 15 or hash 30? Hash 30 means total time period is talking about, right? Total time is nothing but 30. Every 30 time unit it has to toggle. Means what is the T on T off should you can give? 15. Forever, hash 15 is equal to 1. Oscillate is equal to what? Not of oscillate. Can you write a program? Tell me the program to this. Let us copy this. You understand this program first. Can you write a program quickly to this? What is the program I should write for this? Is module TB reg what? Oscillate. Then what I need to do? Initial begin. Initial begin. He's talking about initialize this to what? Initialize this to what? One tick B 0. Then what I need to do? Forever. Hash 15. Correct. Oscillate. Oscillate. Right is equal to what? Not of oscillate. Not of oscillate. Then I need to end this. In another initial block, initial begin, I am going to monitor this. Correct. So dollar symbol monitor of what I need to monitor. Time. Then what I need to monitor? Oscillate. Oscillate is equal to what? Percentage B. What is the argument I need to pass? Oscillate. Correct? Then this forever will be stopped whenever it is encountering what? Disable block or dollar symbol finish. I can use the dollar symbol finish here. Dollar symbol finish. Then what I need to do? End this initial block. Then end the module. End the module. Did you understand? Now this oscillator will be toggles at what time unit? 30 time unit, correct? Let us run this program. You can see this output. Okay, let us understand this output. At time t is equal to 0, what is my oscillator is? 0. Now at time 15, 1. At time 30 unit, what happens in? It is toggling. Again at time 45 minutes, at every, what he is talking about is, at every, it make it toggle every 30 time units. Then it should toggle at what time? 0. But it is toggling here only. What I want to do in this program? Is it as 20 or as 30? As 30. Correct. At every 30 time unit, it has to toggle as 30. Let us run this. Now here it is 0. Correct. Now let us copy this and see the output of this program. Now time t is equal to 0, oscillate is equal to 0. It toggles at what time? 30. Again it toggles at next what time? 60. Again what time? 90. At every 30 time units, it is toggling. So this I have done using what? Actually it is nothing but a clock generation. Clock generation done using what? Forever in the initial block. Forever in the initial block. Are you understand this program? Now can you answer to the next question? Now can you tell me what is the answer to this? Design a clock with a time period of 40 and duty cycle of 25% by using always and initial statement. Always and initial statement. The value of the clock at time t is equal to 0 should be initialized to 1. 0. Can you write a program to this?
Hello. Okay.
Can you write a program to this? He is talking about the design a clock. We need to design a clock with the time period of what? 20. But duty cycle is nothing but what? 25%. Can you write a program to this?
आराम से बैठना है सब प्लीज है ना मैं तुमसे ज्यादा नर्वस हूँ तुम इधर उधर हिलोगे तो ये बहुत सारे होंगे इनके बाद ज्यादा पढ़ने को होता नहीं
What is the program to this?
आराम से
What should be the TR for this duty cycle of 25%? What is the duty cycle is? How to calculate the duty cycle? What is the total speed he is talking about here? TP is equal to 40. Total period it is. You know that T on plus is nothing but what? TR. Now to define the duty cycle, duty cycle will be what? Maximum number of T-ons divided by TP. Correct. Now he has given the what? Duty cycle. Duty cycle is what? 25%. And his time, total time period also is given. What is total time period is? 40. Now this is nothing but what? TR. What is TR now? Is it 10? What is 25% into 40 means what? T-on should be 10. T-on should be 10. Then what is T-off? T-off should be 30. T-off should be 30. Then how to generate the clock with this duty cycle? 25% duty cycle. using initial block and always block. Now you are declaring the reg clock, correct? In initial begin, doing. You are initializing clock to 1 tick B0. Then you are ending this. Always begin, correct? Always begin. Is it the hash 5? T on should be how much? T on should be 25% duty cycle I need to generate. Hash 30, okay. Clock is equal to 0 or 1? Is equal to 0. Again, hash 10, clock is equal to what? 1. Then what I need to do? End the always clock. The always clock. Is this is a clock generation with 25% duty cycle?
The screen is not visible, sir.
Yeah, hello? Hash 30, clock is equal to 1. And then hash 10, clock is equal to, is it 0 or 1? Duty cycle is 25%. 25% should be on time, and then 75% should be what? 25% time should be T on, 75% should be what? T off, to generate the duty cycle of what? 25%. Hash 30, how much time I need to turn off? 75%. 75% is 0, and then hash 10 is nothing but 10. Let us write a program and we'll understand this. Okay. How to write a program to this? So module, instead of reg oscillate, I can use what? Clock. So this initial begin is for what? Initializing the clock. He's talking about initial begin. Now I'm initializing this. Now I'm going to remove this here. Correct? Then I'm going to use what? Always block, always begin. What I need to write here? Hash 10. What I need to write? Clock is equal to 1 tick B 1. Correct. Next, hash 30. Clock is equal to 1 tick B 0. Then I'm going to end. Here what I need to monitor? I need to monitor the clock. Clock here I need to monitor the what? Clock. Did you understand? Now let us run this. So line number 19, let us remove this. Run this program. Can you calculate the time period of this and then see what is the duty cycle of this clock generation? Huh? Is this is 75%? What is the total time period is?
40.
Is it 40? Total time period is 40. So how much time it is T on is? How much time it is T off is? 30. So T off will be 30. T on should be how much?
10.
Is this is correct?
No, sir.
What is it to 25% duty cycle? 25% duty cycle is nothing but, if I write the clock, T on should be how much time? 25%, correct? T off should be how much? 75%. Out of 100%, this should be half, and this much be what? 25. Then you know that what is a duty cycle, right? Duty cycle is equal to what? Maximum number of T earns divided by total time period. Total time period. Now I want a clock that 25% duty cycle means 25% should be T on and 75% should be what? TL. So how to generate the clock to this? Is it T off should be 4 or T on should be T on should be 4 or T off should be 6? See, in this it is straightforward question. There is no confusion. He has given the duty cycle. How much he has given? 25%. He has given time period answer. What is time period is? 40. You find out what should be the T on, what should be the T off to this. T off is, T off should be 30, T on should be 10. How you calculated this? 25% means how much was? 25% means how much?
1 by 2.
Is it 0.25 or it will be 10?
0.2.
This is nothing but you are saying this is nothing but 10. Then what is T on should be? 25%. How you can calculate that 25%? 25 divided by 100 into, okay, first you tell me what is the result of this is. This is how many times? 4 times. So 1 by 4. 1 by 4 means what? Point 0.25. Correct. 0.25 into what is TP is nothing but 40. What is this T on is? Now 0.25 into 40, 10. T on should be what? 10. Then what is T off should be? So total time period you know. Correct? This is nothing but 30. Then how to generate this clock? With the duty cycle of 25 and duty cycle of 25. T on should be 10. T on should be 10. I am making clock is equal to what? 1. T off should be, clock is equal to 0 means what? Half period. T off should be what? 30. Now you can see this output, it is generating the 25% duty cycle. Okay, let me run this program using model sim and analyze the timing back. Okay, so let us run this program. What is the run.do file? Run.do file, what I need to write? So I'm giving this is tb.v. Now let us save as run.do file. All files save. Now this is my duty cycle program. Let us remove this. Let us open the model sim and do run.do file. Now can you see this output? This is what at time t is equal to 0. But this is at what? At time t is equal to 40. Right, total time period is nothing but what? 40. Now this is generating what duty cycle? 75% duty cycle. So how to make this into the 25% duty cycle? Huh? What I need to do? Now this should be what? 30%. This should be what? 10%. Did you understand? The total time period is nothing but what? 40. Now let us run this problem. Now can you see this program? T off should be how much? T on should be how much it is? 25%. And this is a T. And this is nothing but what? T off. So we have generated the clock with 25% duty cycle. 25% is on. 75% will be what? Off. Did you understand this program? Are you clear? What is 50% duty cycle? T on duty cycle should be same as on what? T on 50% duty cycle. This is clear? So today let me do one thing. I will be sharing you few assignment questions on the behavioral model. Okay, this is the questions what I was talking about. These questions. Okay, try to find the answer to all those questions. Okay. So any questions which you are not able to understand, not able to find the answer, we will discuss in the next session. Okay. So in the next session, I will be talking about generate statements. Okay. After that, we'll go with the tasks and functions. Okay. Today you work on the examples of sequential block and parallel blocks. How to use the poke and chant. And then you can work on the loops. For loop, repeat loop, and then forever loop. So with this, I'm going to stop the session here today. Next session will continue with the other topics. Okay. So now I request all of you to fill the attendance. Yeah, hello, online student, any questions? You can please go ahead.
Sir, that always block.
Hello.
Now you right?
No, your voice is breaking. I'm not able to hear what.
Now you can hear, sir.
Now somewhat okay.
So 1 minute.
Hello.
Hello, sir.
Can you put a chat box message?
Okay, sir.
Hello. See, there's a question that, how does the always loop for the clock know? Here you can see this program. What we are doing? This initial block is to initializing to initially clock to what? 0. This always block I'm using for what? Generation of the clock. How this always block will works? It is keep continuing like a looping fashion, right? Inside this, I'm what? I'm generating the TR. of this much and t up to this much. Correct. The same thing you can achieve using the forever, right? How you are achieving with the forever? You are writing forever, correct? Then you are writing what? Then give the time, simulation time. Let us give. This is how you can write the forever, right? As time period, you are giving time period.
Begin and end should be there, right, sir?
Then now you can go with what? Begin and end. Then you can write what? As 10, clock to what? 1. Again, as 30, clock to what? 0. Then you end up forever. This is same as in what? Always. Correct. This is same as in what? Always. But here initialization is done using what? Initial begin. I'm initializing this what? Initial begin. What is the initial begin? What is the use of the initial begin? The one-time execution, it is used to initialize the what? Values. Right? It is used to initialize the values and it is used to monitor and displaying purpose. We'll be using what? Initial begin. Most of the time it is used to prepare in the test benches. But these are the kind of operations. Correct. Now in this initial begin, I'm using what? Clock initialization. Then I'm using this forever. This should be executing only one time execution. But I'm writing inside this forever, right? Until this forever encounters the dollar symbol finish, this initial begin will be executing. Are you understand? So this is one way to write the generation of the clock. Another way is nothing but you begin. So in our example, so what we have done is nothing but clock initialization is done in what block? Initial begin. Then clock generation is done here. For this time stamp, clock is equal to what we are doing. Clock is equal to 1. And then this time period after this, clock is equal to what? 0. So this will generate a clock of duty cycle of 25%. This is clear?
Yes, sir.
So here when this initial, if I'm using initial forever here, all these are concurrently executed, right? This will be executed at time t is equal to 0. This also executed at what time? At time t is equal to 0. And this initial block also what? Time t is equal to 0. So end is depending upon what? End is depending upon the statement which you are using in all the blocks. Correct. All are concurrently executed. So once this dollar symbol 500 happens, it will finish because all these are concurrently executed. This also time t0, this also time t0, this also time t0. But end is depending upon what? At 500 times time. You understand? So this is keep executing. If I'm using forever here, that forever will be keep executing. Once it is encountered with this hash 500 dollar symbol finish, now that forever will be what? Stopping the iteration execution. Basically, you should understand that how this initial block and all these blocks are executed. These are executed what? Concurrently. The time execution is same time. Time is equal to 0. So end termination of these blocks will be depending upon number of statements you are using in the procedural statements. There is no break here. I'm not. If you want to break this, what I want to do in one of the initial block, I should use the what? Disabling the block. If I want to see my program like a break operation, what I want to do, I can go with the named block and then what? Disabling the block. Now here I'm using what? Dollar symbol finish. Once this encounters, it is going to stop the iteration. So with this, let me stop the session here. So we will continue in the next session.